Scientists study sea levels 125,000 years ago, and it's a terrifying look at our future. This is by Fiona Hibbert, EELCO Rowling, and Catherine Grant. From the conversation, it's on Science Alert. Sea levels rose 10 meters, that's above 30 feet, over the present levels during Earth's last warm period 125,000 years ago. That's over 30 feet, according to new research that offers a glimpse of what may happen under our current climate change trajectory. Our paper, published today in Nature Communications, shows that melting ice from Antarctica was the main driver of sea level rise in the last interglacial period, which lasted about 10,000 years. Rising sea levels are one of the biggest challenges to humanity posed by climate change, and sound predictions are crucial if we are to adapt. And this research shows that Antarctica, long thought to be the sleeping giant of sea level rise, is actually a key player. Its ice sheets can change quickly and in ways that could have huge implications for coastal communities and infrastructure in the future. A warning from the past. Earth's cycles consist of both cold glacial periods or ice ages, when large parts of the world were covered in large ice sheets, and warming interglacial periods when the ice thaw and sea levels rise. The Earth is presently in an interglacial period which began about 10,000 years ago. But greenhouse gas emissions over the past 200 years have caused climate changes that are faster and more extreme than experienced during the last interglacial. This means past rates of sea level rise provide only low-end predictions of what might happen in the future. We examined data from the last interglacial, which occurred 125,000 to 118,000 years ago. Temperatures were up 1 degree centigrade higher than today, similar to those projected for the near future. Our research revealed that ice melt in the last interglacial period caused global seas to rise about 30 feet above the present level. The ice melted first in Antarctica, then a few thousand years later in Greenland. Sea levels rose up to 3 meters, that's over 10 feet, per century, far exceeding the roughly 0.3 meter rise observed over the past 150 years. The early ice loss in Antarctica occurred when the Southern Ocean warmed at the start of the interglacial. This meltwater changed the way the Earth's oceans circulated, which caused warming in the northern polar region and triggering ice melt in Greenland. It's almost like we're seeing now, isn't it? Understanding the data, global average sea level is currently estimated to be rising at more than 3 millimeters a year. This rate is projected to increase the total sea level rise by the year 2010 relative to 2000 is projected to reach 70 to 100 centimeters, depending on which greenhouse gas emissions pathway we follow. Such projections usually rely on records gathered this century from tide gauges and since the 1990s from satellite data. Most of these projections do not account for the key natural process, ice cliff instability, which is not observed in the short instrumental record. This is why geological observations are vital. When ice reaches the ocean, it becomes a floating ice shelf, which ends in an ice cliff. When these cliffs get very large, they become unstable and can rapidly collapse. This collapse increases the discharge of land ice into the ocean. The end result is global sea level rise. A few models have attempted to include ice cliff instability, but the results are contentious. Outputs from these models do, however, predict rates of sea level rise that are intriguingly similar to our newly observed last interglacial data. Our work examines records of total sea level change, which by definition includes all relevant natural processes. We examined chemical changes in fossil plankton shells, in marine sediments from the Red Sea, which reliably relate to changes in sea level, together with the evidence of meltwater input around Antarctica and Greenland, This record reveals how rapidly sea level rose and distinguishes between different ice sheet contributions. Looking into the future, what's striking about the last interglacial record is how high and quickly sea level rose above present levels. Temperatures during the last interglacial were similar to those projected for the near future, which means melting polar ice sheets will likely affect future sea levels far more dramatically than anticipated to date. The last interglacial is not a perfect scenario for the future. Incoming solar radiation was higher than today because of differences in Earth's position relative to the Sun. Carbon dioxide levels were only 280 parts per million compared with more than 410 parts per million that we have today. Crucially, warming between the two poles in the last interglacial did not happen simultaneously, but under today's greenhouse gas-driven climate change, warming and ice loss are happening in both regions at the same time. This means that if climate change continues unabated, Earth's past dramatic sea level rise could be a small taste of what's to come. This is by Fiona Hibbert, postdoctoral research fellow, Australian National University, Elko Rowling, professor of Ocean and Climate Changes, Australian National University, and Catherine Grant, ARC DECRA, postdoctoral research fellow, Australian National University. Article republished from The Conversation under Creative Commons license, and this is on Science Alert. What we're seeing here are images of erosion. These are land areas near the sea. This is erosion by the sea. These are multi-million-dollar homes, seaside homes, and you can see here part of the home is gone, the pool is gone, and not just this home, but the whole stretch of land with all these multi-million-dollar villas on the sea is basically they're falling into the sea. The sea is just about carrying everything away. And this is something of a foretaste of what we'll be getting. The United States has very low-lying areas. The eastern seaboard is all low-lying. Years ago when I went to, for one example, Hilton Head in North Carolina, we had a rainstorm and we were we had a blackout. We didn't have power for days. Forget our worldwide meeting that we had. It was just a disaster. We didn't even have refrigerated food. They had to give us jam and toast. No coffee, no tea, or nothing. And everything was underwater. And that was just a regular rainstorm. So that's how low-lying a lot of parts of the eastern seaboard are. They're talking about creating levees around New York City because of the fact that it's that terrible. Billions of dollars, tens of billions of dollars to reinforce levee systems around Staten Island, the Manhattan Island, because of the fact that it would be flooded very often. And this goes, again, towards the West Coast, the same thing. As we know, one of the videos that I made yesterday having to do with the subsidence of, it was a public lecture on the land subsidence because of the withdrawal of the groundwater. And since 1935 to 1965, the land had subsided over 2008, I think. The land subsided a total of 40 feet. 40 feet. You can imagine that the whole valley there had subsided about 40 feet because of the withdrawal of the water, and it was basically California is sinking into the ocean. So this is very, very important news because most of the communities worldwide are oceanfront properties, riverside properties that will have this problem. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not certainly on not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.